Welcome back, everybody. Okay, so this was your problem here, and let's see what people came up with, if I can find it. Great. Okay, good. So I'm on my phone, and I need to pick a 3-digit PIN number, or even a 4-digit PIN number, right? That's very common. What do I do? Pick me. All right, so here's my phone, right? I'm picking a 4-digit PIN. So what am I doing first? What's the first thing I do? I pick a number. Yeah, I hit it once, right? So I hit it one time, and how many choices do I have? 10. Good. So I'm going to do that over and over again. If I'm picking a 4-digit number, I do it 4 times. If I'm doing a 3-digit number, I do it 3 times. So I'm making 4-digit PIN, I'm making 4 decisions. 3-digit PIN, I'm making 3 decisions. Right? I'm picking a number each time. So let me show you what I mean. I'm making 3-digit security PIN, I'm making 3 decisions. The first decision, I have 10 different options. How many options for the second one? 10. Third one, 10. So again, draw these lines to tell you, to kind of set out how many decisions you're making. It makes your life so much easier. I've had multiple students tell me how much easier it was once they realized they should draw the lines.
Professor?
Yeah.
Right, 10 options, where does that come from?
Digits. First thing I do is I pick a number on my phone, right? I'm picking a 3-digit PIN. What's the first thing I do? I open up my little PIN number thing, my little telephone thing, and I pick a number, right? Can you guys see that? Okay. Right. So I pick a number on my phone of the 0 through 9. Is that you see what I'm saying?
Yeah.
So say I wanted. I need to pick, I'm literally on my phone looking at what number to pick. I need to pick a 3-digit PIN. So I picked 3, 3, 4. But the first 3, I could have picked 0, or 2, or 1, or 7, or 9. You know what I'm saying?
Oh, well, I'm just trying to figure out the 10, because it's only one, I don't know why it's...
1 through 9.
0 counts as a number. I think that's what she's asking.
Yeah.
10 digits, because 0 is also a number. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 10 digits.
Ha! Thank you.
You're welcome.
You guys are awesome. I love you guys. All right. Perfect. Good. So hopefully this makes more sense. People kind of got the 2-digit one pretty well, so that's good. Excellent. Now we're going to talk about more counting rules, factorial. It's a part of all positive numbers from 1 up to that number. So for example, 3 factorial would be multiplying all the numbers from 1 up to 3. Or I like to think of it as 3 down to 1. So I start with 3, and I go all the way down to 1. So 3 factorial would be 3 times 2 times 1, which is 6. That's also the number of ways to arrange 3 things. So for example, red, blue, and white can be ordered 6 ways. Here they are. Why is that? Because for the first color, how many options do I have? Red, blue, white. I have 3 options. Once I choose one of them, then for the second color, I only have 2 options left. And once I choose that one, then I only have 1 color left to pick from. Does that sort of make sense? So here, like red, white, blue. If I choose red, then I only have a choice of blue or white for the second color. And then once I pick one of them, I only have 1 color left. That's the one I have to pick. So again, 3 factorial is the number of ways of arranging 3 items. Oh, sorry, I need to take a picture of that. So you guys find 4 factorial. Everyone find 4 factorial and private chat it to me. Quickly, quickly, quickly. Next one in there. So 4 factorial. What is 4 factorial? I'm totally off on this. Darn it. Okay. All right. Looks like I have a whole bunch of answers in there. Great. 4 factorial is, yep, I start with 4 and multiply all the way down to 1, which is 24. That is the number of ways of arranging 4 items. Why? Because I have 4 choices for the first spot. I only have 3 choices for the second spot. Once I take that one, I'll have 2 choices for the next spot, and then the last one I only have 1 spot, so I don't have really any choice. It's just that one. Here it is looking at a tree. So the first choice I have, the first draw I have, first position I have 4 choices to choose from. Once I pick one, like say I pick this one, then now I only have 3 things left to pick from. Then I pick this one, say, now I only have 2 left to pick from. Then once I pick one of those, I only have 1 thing left. So there's 24 possible outcomes that you can choose from there. All right, so who's ever seen a horse race? Anybody?
Sure.
Yeah, they're pretty cool. And typically they care about the top 3 finishers. How many ways, if I have 8 horses in the race, how many ways how many different possibilities are there for the top 3 spots? So first question I want to ask you guys is, how many options are there for first place? How many horses could possibly win first place?
8.
8 horses, great. Now, after one comes in first, how many options are there for second place?
7.
Yep. And after that, how many options are there for third place?
6.
Great. So if I have 8 horses, and I'm trying to figure out how many they can finish, I'm kind of picking the top 3 spots. I'm making 3 choices. I'm going to start with my 8 in the first spot, and I'm going to count down 8, then 7, then 6. This is a special case of the fundamental accounting principle called a permutation. It's when you cannot reuse, you have one pool of items, one group of items, and you cannot reuse items. And order matters. It matters what order they're in. It's written, sometimes it's written as P parentheses 8 comma 3. This is actually a function, P of 8 comma 3, or more likely you'll see it written like this, 8P3. It means I have 8 items and I'm picking 3 of them in a particular order. Oops. Mouse. Now, what if I wanted to record the finish of every horse? Now, how many possible finishes are there? So, how many horses am I picking? 8. 8 spots. So, draw the lines. It makes your life easier. I'm picking 8 of them. I'm going to draw 8 spots. How many options for the first spot?
1.
Think of it the other way. I haven't picked any horses yet. I picked no horses yet. 8. So I have all of them. I have all of them at my disposal. I can pick any of them. Now, after I pick one, how many left?
7.
Yep, and then?
6, 5, 4, 3, 2.
Yep, 5. Yep, 4, 3, 2, 1. I'm going to multiply all of them. That is the way of having 8 horses and selecting all of them, right? So this is another way of looking at how many ways can you arrange 8 horses or put 8 horses in order. We just found that earlier. We said that was 8 factorial, right? This is 8 factorial. Start with 8 and multiply all the way down. So 8 factorial is really just a special case of permutations. When you have when you're selecting, I got it. Do that better. That's not going to look good. Undo. When you have 8 of them and you select all of them, 8p8, that's the same thing as 8 factorial. So a permutation, factorial is just a special case of a permutation when you are selecting all of them, every one that you have. Not a big deal. You don't need to know that. Just I thought it was interesting. but you do need to know how to find, any question that I kind of throw at you like this.
Wait,
But
doesn't order not matter in this case?
it does. It matters. I want to know record the place of every horse. So that's where you came in first, second, third, fourth, or fifth, all the way down to whether you came in seventh or eighth. I care if you came in seventh or eighth. I'm recording the finished place of every horse. So, good question. I'm glad you asked it. It does matter. Do you guys want to look at that again?
So for the answer for this one, there'd be like 40,000.
A lot. Yeah. Something huge. Something really, really, really big. See if anybody gave it to me.
Well, 40,320.
Yeah, that sounds like it. That sounds about right. 40,000. Would you say 40,000?
320.
320? Yeah, that seems about right. Good. Okay. Let me clear that. And move on to the next one. Oh yeah, so here's an example. Let's get a reader. Hunter, go ahead and read for us.
Example, radio show guests. A radio talk show host can select 3 of 6 special guests for her program. The order of appearance of the guest is important. How many different ways can this be done? Since the order of appearance on the show is important, there are 3 ways to select the guests.
Does that make sense? Oh, that's good. You're okay, that's good. Thank you.
Yep.
So, I'm selecting 3 out of 6, so it's 6, I'm picking 3, 6P3. What does this mean? That means I have 3 spots, boom, boom, and boom. Oops, it's kind of crooked. And I got to start with 6. So this one here tells me how many places I have. That's what the 3 does. It tells me how many spots I'm picking. The 6 tells me what number I start with. 6. Does that kind of make sense for folks? And then you fill in the rest of them. 5, and then 4. I'm sorry, was it a question?
No, you finished it.
Okay, great. So then we end up with, let's see, 120, looks like. Perfect. So here the N, so a lot of times you'll see NPR. So here the 6 is N, the number of things I have, and R is 3, the number of things I'm selecting. So it's important that you know that. I more care about you understand this part here. Go zoom tight. Okay, clear that. And let's move on. Oh yeah, here it is again, prettier. And you guys do problems 22 and 23. So hop into your groups and do those. Okay, welcome back. You're on me. Oh,
And we have returned.
thanks, you guys. I appreciate you keeping me on track because I forget that every time. I hate that it does that. All right, great. So lab problem 22. Certain model of automobile is available in 7 exterior. Okay, so here we're making choices. So the question is, remember when you hit this twice, it gives you options here. You can pick a highlighter, different colors. It's in 7 exterior colors, 3 interior, 3 interior styles. Transmission can be manual or automatic, and it can have 4 or 6 cylinders. So we're making 5 decisions. You should have 5 lines here. And then how many options? So the first one, 7. The next one, 3. Next one, 3. Next one, 2. And 4, 6, that's 2. So that's what you're multiplying. 252 versions. That seems good. Let's look at the next one. Someone had, oh, this is pretty good. Okay, good. So, door prizes. Does it matter what order it's in? Does it matter when you get a trip to Vegas versus if you get a $10 gift card? Do you care if you get a trip to Vegas versus a $10 gift card?
Yes.
I do. Oh, yeah, order totally matters, right? So here, order matters. We're picking from a pool of people, and we cannot reuse people, so it's going to be a permutation. All right, so let's see. We're awarding 3 prizes, so we're going to have 3 spaces. Yeah, they have this 3 spaces, 1, 2, and 3. And we have 112 people that we're starting off with. So 112 goes first, then 111, then 110. So this seems like that could be accurate. Anybody else get that same answer? Anybody else get the same answer?
We got the same answer in my group as well.
Okay, that seems good then.
Like, can you go to, like, can you go to our jam room? Like, you know, our answer, I don't know if we got the same answer.
What number are you?
You'll know.
I'll know. That one?
No.
That one?
It's that one.
You figure out the other question. We're not there yet.
Oh, man.
This one?
Yes.
Yeah. All those are good. Yeah, so it's 112 P3. Right, so 3 spaces, and you're going to start with 112 and multiply down. Good. Okay. Now, this is just it, you know, slightly prettier. I don't know, it's really prettier. It's probably not really prettier. All right, so now, hopefully you guys totally have that down, because now we're going to talk about if order doesn't matter. If order doesn't matter, for example, I want to pick 3 chaperones for a field trip. I can choose between Alex, Ross, Laura, and Rigo. How many ways can I choose 3 of them if order doesn't matter? First of all, everyone agree that order doesn't matter? I'm just taking three chaperones. So if order doesn't matter, there's 4 ways. You can think of it as everybody except for Alex, everybody except for Ross, everybody except for Laura, everybody except for Rigo. That's, 4 different ways, right? Now, what if order did matter? If order mattered, then it'd be slightly different. So, let's see. Here I would go 4P3 if order mattered. So that would be 3 spots. 1, 2, 3. I'd start with the 4. 4 options for the first job, 3 options for the second job, 2 options for the third job. So that would be 24. So if order matters, it's 24. Everybody on board with that? If order doesn't matter, it's 4. Okay, we'll come back to that in just a couple minutes. Oops, that didn't go. Okay. Now, if order does matter, say I picked Alex, Ross, and Rigo. I picked those 3 guys. And order matters. The first guy is going to count the children, make sure all the children are on board. The second person is going to gather up all the lunches, get all the, the lunch, go over to the cafeteria, pick up all the lunches for them. The third person is going to make sure that all of the directions, the bus driver has the directions and knows where we're going and has all that stuff down. So how many ways can I arrange that or order, so this first spot, for example, the counting the kids and putting on the bus. How many options do I have for someone to do that? How many choices? 3. Alex, Ross, or Rigo. 3 choices. Now, after I assign someone that job, how many choices do I have for someone to go grab the food from the cafeteria?
2.
2. Perfect. And then, whoever's left, that last person is going to be the one giving the bus driver directions, right? So 3 times 2 times 1, 6 ways of arranging them. Good. How do you find that with factorials again? Do you guys remember? That's the same thing as 3 factorial. 3 factorial is the number of ways, 3 times 2 times 1, that's 3 factorial. That's the number of ways of arranging 3 items. N factorial is the number of ways of arranging n items. So 3 factorial will be the number of ways of arranging 3 items. So here's the big kicker. If order matters, there are 24 different ways of picking these 3 people, or 3 people out of these 4. If order doesn't matter, there are 4 ways of selecting 3 people. How do I get from 24 to 4? Well, I divide by 6, but why am I dividing by 6? So I'm going to take 30 seconds and try to figure out why am I dividing by 6? That's my question. Try to figure it out. Color matters. That's a hint. My hint is color matters. Nope. Tell me. Any guesses? Go ahead. Just say it.
Take options with each set.
Yeah. 6 options with each set. So in other words, this set, explain what's up with this set. Why is this a set? And they have
Names of the people.
Yeah, it's the same names, just rearranged. The same people. All of them in the red group, those are all Alex, Ross, and Riga, just arranged in different ways. The green ones I'm circling now, those are all Alex, Laura, and Rigo, just arranged in different ways. Right? So 6 is the number of ways of having 3 items and arranging with them. How many ways can I arrange 3 items? 6 ways. 3 options for the first name, 2 options for the second, 1 option for the last, 3 times 2 times 1, 6. So really, what this is we care about how many groups there are. Right? If you're talking about order doesn't matter, we don't care how many groups there are. Order matters, we care about each individual one. But if order doesn't matter, then we count this as one whole clump, one whole group. Right? So we need to divide out the duplicates to figure out how many groups there are. Divide by how many people are in a group, then you see how many groups there are. How many people are in a group? 3 factorial in this case. In other words, whatever this number is here, how many people you choose, that many factorial. If there's 3 people in there, 3 factorial. If there are 4 people in there, it'd be 4 factorial. Questions about this? So here is the kind of the conclusion I'm telling you. If order doesn't matter, then if order matters, it's 4P3, right? If order doesn't matter, then it's 4C3 combination, and that's the same thing as a permutation divided by R factorial. So in other words, if order doesn't matter, you divide by the number of ways to arrange or arrange R items, R factorial. So you might say, well, what do I put in my notes? Great question. I love that question. Let's see, what should we put in our notes? So where's our notes? Our notes are over here. And we're down, say, right in here, right? So you put in here factorial is the product of all positive numbers, blah, blah, blah. A permutation is an arrangement of objects in a specific order. Order matters. So here I would put for NPR, I would suggest you don't put the formula because the formula is just annoying. Instead, I would say you start with N and multiply down R spots, right? So that's, in other words, if I have 4P3, I would start with 4, right, my N, and multiply down 3 spots. There's the first spot, there's the second spot, There's the third spot. Does that make sense for folks? Three spots. And then you start with 4. For NCR, again, I would put, that's the same thing as N, oops, this is going to be awful. I cannot write with this in my mouse. Okay, let's try it again. N, P, R, over R, factorial. It's just, here I'll tell you what you should do. Just write down here, write down that. Does that make sense? That's what I would say. Just write down that. Okay. Any questions about this? Everybody's happy? Happy, happy, joy, joy. Ron's like, yes, I'm happy. Good deal. As long as Ron's happy, all is well in the world. Okay. This is just another way of putting it. Again, here are the formulas, which the book will give you. I think they're confusing and just more frustrating because they're not intuitive in any way, shape, or form. So, yes, they're there, blah, blah, blah. I really don't recommend them at all. I'm just going to skip right through that. Oh, but this is sort of interesting. One of my old classmates, students, what she said was, the way she remembers if order doesn't matter, that's a C, is if order doesn't matter, they're all mixed around going wherever, it's chaos. So that's how she remembers that's the C. And that's the one you divide by. When it's chaos, that's when you divide out the duplicates. So I guess it's kind of useful for that. All right, so let's look at an example. How about Meg? Meg M, go and read for us. I haven't heard from you today.
Example, flyer type. An advertising executive must select 3 different photographs for an advertising flyer. If she has 10 different photographs that can be used, how many ways can she select 3 of them?
Great. So in this case, we're saying order doesn't matter. We're just picking 3. So I'm selecting 3. If you're selecting 3, that means you're going to have, and you have 10 of them. You have 10 C3. Selecting 3, I'm going to have 3 spots. Boom, boom, boom. And then, since I have 10 photographs, right, 10 photographs, that means that I start with 10 right there. And then I multiply down the rest of them. Or the rest of them, let's see, that's 9, and then 8. But we're not done yet. Because it's a C, you have to divide out the duplicates. So I'm going to divide by, and the beautiful thing is, since there's 3 of them, I divide by 3 factorial. So for every spot, when I draw these lines, I have to match up a number for each one of these numbers. So 3, 2, 1. Or you could even go 1, 2, 3. You can count up, right? 1, 2, 3. Or you can go 1, whatever you want. 1, 2, 3. You can go the other direction. So this will end up being 720 over 6 or 120 is the answer. Just pick a different color for that. Oh no, did I just, no, that's okay. 120. Great. So now you guys have, oh, we're over time. Crap. Okay, well you have 2 problems. You can either do them in your groups or you can do them on your own, but it's these problems here in your Jamboards. So problems 24 and 25, you have to get done for today. You're turning in page 17 today, but you need to do 25 and 24. So if you want, I'll put you in your groups, and you're welcome to hop in your groups and do them, or do them on your own. But I do need those turned in today as part of your work today. So here are the rooms. If you don't have them, if you can't get them figured out in the next 4 minutes, I'll pull you back in and we'll go over them in class to make sure that you have them before you leave.
Wait, Michelle, so you want us to include Lab 25 on our picture that we turn in?
No, but I do want you to do it, because if you don't do one right away, then it's going to make it harder to remember how to do it next time. Do you know what I mean?
Okay. Yeah.
So for the sake of your own learning, you should do 25 today.
Okay.
Because you have an exam coming up and you want to be able to do well on it. And 100% is going to be in there.
What pages would you like us to turn in today?
17 and also quiz 4.3.
Got it, thank you.
You're welcome. So I'll pull you guys back in 3 more minutes to see if people want to go over it.
I actually had a question. I didn't want to hold everybody back.
Totally.
I am having trouble understanding. So I understand when, like, the top numbers for the conditioning.
Yeah, totally.
Where it was like 654.
Yes.
There was this group.
Yep. So then the beauty of it is 654. All you have to do is figure out. Here's this one. Oh, sorry, mouse. Right, so you got the 1098, right? That makes sense?
Yeah, I understand that.
So then, however many spots you have, I've selected 3 items. Do you see what I mean? I've selected a 10, a 9, and 3. That's 3 choices I've made.
Yes.
So I need to divide by 3 factorial. 3 times 2 times 1.
How does that change for when it's
That's
when order?
That's when order does not matter. If order matters, then I just leave it at 10, 9, 8, done. 10 times 9 times 8.
Oh, okay. So you only add the number of selections for the
I only
factorial when an order doesn't matter.
Exactly. When order doesn't matter, I add in the extra step of the divide by 3 times, divide by the 3, 2, 1 on the bottom. Otherwise, it's just a 10, 9, 8, done.
Perfect. Okay, thank you.
Oh, thank you. Okay, my fault. I think things are a little bit confusing for you guys. So here, the first question you have to ask yourself is, do I have a pool of people where I cannot reuse people? Yes. I have 12 members. I can't use them over and over again. The second question to ask yourself is, does order matter? Does it matter if you're president versus if you're secretary? Yes, it totally matters. So if it matters, then you're just doing a regular permutation. If you're doing a regular permutation, it's just permutations are, again, just make sure you guys are clear, it would be 12p3 if order matters. So you would just draw 4 spots like they did. The first one starts with the 12, 11, 10, 9, done. That's it. So order matters. It's just this regular thing, not complicated, very straightforward, nothing weird. Order matters, permutation, all good. That's the regular
it
thing.
seems like for any one of these problems, you can argue that order matters or it doesn't.
Okay, so think of it like this. If when you pick them, you put them in a particular place, then order matters. If when you pick them, you just throw them into a bin and they're all kind of rolling around wherever, then order doesn't matter. If I'm picking someone and saying, you are president, you are vice president, you're treasurer, you're secretary, then order matters. Does that make sense? If I was saying, I just need to pick 4 people to help on a committee, then order wouldn't matter.
Is it also safe to say that if the word problem kind of has it ranked, like president, vice president, treasurer, and secretary, then it's obviously order?
If it spells out specific positions or specific jobs, like if I said, I need 3 chaperones, 1 to wash dishes, 1 to mop the floor, 1 to take in tickets at the door, then then order would matter, because now I'm assigning them each a job. Do you see what I'm saying? So if they are getting assigned something, like I'm picking 9 players to be on a baseball team, and and I'm going to give them each a position. Now, order matters.
How does the position matter?
Because it matters whether you're pitcher or whether you're first base.
Not if you're a first place player, like you were.
Oh yeah, if you're a first base player, would you want to be thrown into the outfield?
Yeah, but if you're a first place player and you got chosen to be a first place player, you could have an argument that being chosen over a pitcher.
I'm not saying, wait, Ron, I'm not saying you get chosen over that. I'm not saying, I mean, if I'm picking, sometimes when you pick, what do you call it? You pick raffle tickets, the grand prize is the last one picked. So I'd rather be picked last than first, because first place I only get $10. If I get picked last, I get $1,000. I'm not saying that the order you pick in is more important than each other. I'm saying it matters because they're different.
For the sake of this class, is there a way you can tell us when order matters?
Yes, when they are assigned a specific job,
Okay.
a position. Right? If I told you that the flyers, like if I did the flyers and I said, I'm picking 3 different photographs, they're all going to go in specific spots, then all of a sudden, order matters. Because one photo would go here, another photo would go on the second page, another photo would go on the third page.
So it'd be basically like, I need 4 baseball players versus I need a pitcher, a catcher, an outfielder.
Yes. Yep.
Okay.
If I say specific, so like I said, the way that one of my students best explained it was, she said, well, I think of it as, if when I pick them, I put them in a specific spot. You are going here. You are getting named John. There's a spot. Like if I pick 4 puppies, the first one I pick is named Spot. The second one's named Fluffy. The third one's named Wiggles, and the fourth one's named Oddball. Then it matters what order I pick them in, because now I've put them in I've assigned something to them. But if I'm just taking 4 puppies and they're all going home with me, not being named, then order wouldn't matter. So it's all about if I'm assigning them something. So let's take a look at this one. Hopefully this will make things a little bit clearer. 200 people buy raffle tickets. 3 winning tickets. First prize is 100, second prize is 80, third prize is 30. Does it matter which order you get picked in? Is there a difference between getting 100, between being picked first and being picked third?
Yes.
Yes. So order matters. This is 200 P3. So I'm going to have 3 spots. The first spot is going to be, let's see, I have 200, so that means that the first spot is going to be 200. The 3 tells me how many spots I have. The 200 tells me what I start with. I think someone did this one, so I'm just going to flip to their page. Oh, I know somebody did it. There we go. There we have it. So here's the number. Now, if each prize is $80, it doesn't matter what order they get picked in. They're all the same. So this would be, I don't like the notation, but I do like the idea. So this would be 200 C3. So that's going to be equal to, it's going to be equal to, I'm going to write here, it's 200 C3, which is equal to 200 P3. I think they meant to write a P here. That's my guess. This should really be P. Why is it not taking the P? Don't fight me. Oh, okay, well now that's gone. Fine, no worries. Make a new one. P. I need to make it bigger. Which is really 200 P3 divided by 3 factorial. So all you're doing is taking what you got in the first one and adding an extra step. If order doesn't matter, it's chaos. You have to do an extra step and divide out the duplicates. You have to divide by 3 factorial. Why 3 factorial? Because it's how many spots you have. How many ways can you arrange 3 items? Does that make more sense now? So you don't, the only time you divide is when you have chaos. When order does not matter. When they're all rolling around in this bin, wherever, willy-nilly, wherever they want. That's when you have chaos. That's when you divide out the duplicates. Otherwise, it's just a regular straight up, this part here, this part here. Does that make more sense, hopefully? All right, you guys all ready to kill it on the exam next week?
Yep.
Good. Good job. All right, have a good weekend.